You guys, all right, enough of that. I want you to sit back and relax. This is a video that you're going to watch in its entirety. Just a great conversation. As Autoline Network talked about, this is a deep dive, but a nice candid conversation from Tadge about the C8 2020 mid-engine Corvette.
Welcome to Autoline After Hours. Gary, we got a hot car in the show today.
Yeah, I know. It's awesome. We've had a lot of vehicles in the studio, but few like this.
As anticipated as this one is.
Yeah, absolutely.
Hey, we got to let everybody know we got Greg Migliore from Autoblog with us for the show too. Greg, great to have you back on.
Thanks for being here. I love what you've done with the place.
Yeah.
Corvette, nice decor.
Decoration, yeah.
C8 tends to spiff up any place it goes.
I don't think we're going to leave it here, though.
Ah, darn it. And the voice you just heard, if you're just listening to the audio portion, is Tadge, the Executive Chief Engineer on the Corvette. Great to have you back on the show.
Thanks. Last time I was here, we had a Corvette right there, except it was a C7.
That's right. A little bit of a different configuration.
A little bit different, yeah. We've been working on this one a while.
We got a ton of questions, and both coming in from the viewers, and me and Gary and Greg have got a million too. But let me just kick off one that came in from Ray Mitrowitz. What was the largest hurdle or challenge you faced in going from front mid-engine to rear mid-engine?
It's really hard to pick one because it's, well, for General Motors, it's a completely new kind of car. We haven't executed one. I mean, you can look at the Fiero or the Corvair. I mean, that's stretching back a long time. It's not like we have a lot of tribal knowledge.
You didn't go back to those cars to figure out how to do this.
No, and we didn't even have anybody who remembers working on those cars. So we basically were starting from a blank sheet of paper. We knew what a lot of the challenges would be. Just coming up with a transaxle that would enable the architecture was a massive challenge. There's nothing on the shelf in the world that would be a plug and play for us, so we had to do that. But I think for us, we recognized early that managing the airflow and the thermal of the car, because you put the engine in the back, you're basically isolating the engine. You don't have the natural evacuation of air because the occupant compartment's in the way. So if you somehow have to get air in and out, and we knew we were setting ourselves up for a special challenge because we wanted luggage room. It's so easy to make the whole back half of the car just an engine dyno. Don't worry about anything else. Just feed air to it, blow the exhaust out the back. But we knew we wanted luggage room.
Golf clubs,
travel bags,
luggage.
and the roof. We weren't going to delete the removable roof, and we didn't want to make people leave it in the garage. So it had to come with you. You had to have a place to store it, and that roof is not small. So we had to figure out a way to do all of that and have the good luggage room, both front and rear. So I think managing the airflow and thermal was one of the trickiest puzzles we had to solve.
Okay, another one we got from Jeff Taylor from St. Louis, Missouri. What's the aspect you're most proud of the car? Ray asked the biggest challenge. Jeff's asking, what are you most proud of what you accomplished?
Honestly, if you'd asked me historically on the Corvettes I've worked on, C5, 6, 7, prior to this one, I have always said the bandwidth. That's what I'm proudest of. The car is awesome on a racetrack. It's great as a daily driver. It's great as a long distance tour. It does a lot of things well. And that's why it fits into people's lives really well. And this one does that too, but it does more. And the thing that I'm most proud of is the ride and handling trade-off. You're starting to see people who've been in the car talking about how it handles and how it rides. People are shocked at the ride quality. I mean, just shocked. It's the most comfortable riding car they have, which adds to that bandwidth, but the architecture really enabled that in a lot of ways.
So from an engineering perspective, there are other mid-engine supercars out there, but you guys also had to make it a Chevy, right? I mean, you had to look at it from the point of view of saying, this has got to be affordable by mere mortals, not just all rock stars and people who have tons of wealth. I mean, how did you address that? I mean, that had to be huge.
We say quite often internally, this job would be so easy if we didn't have to worry about cost. You know, if cost was no object, you know, if you're doing one of these cars that you sell a few of and you sell them for a couple $1 million, man, just pick the best solution and go. Make everything out of carbon fiber. But we can't do that. Value's been a huge part of the Corvette and Chevrolet proposition since the car started, and we didn't want to walk away from our traditional customers. We couldn't take a big price increase. So, we have a lot of advantages being part of General Motors. A lot of the things that we do in common with other cars, we get really good prices on. We build the engine in Tonawanda alongside of truck engines. So, the things cost a lot less for us than somebody who's doing everything bespoke. So we have to leverage those opportunities where we can, but not overdo it so that it's not a Corvette. We have a lot of very custom, very specific parts on this car that make it a Corvette, make it a high performance sports car, and we can't compromise on any of those. So it's a big challenge, quite honestly. Finding suppliers who want to work with us, produce parts in these kind of volumes, not always the easiest thing to do.
What was maybe the biggest surprise as you were going through the development process? You talked about challenges. What just maybe just popped into your, your consciousness and thought, oh, hey, this is going to work,
For me, what I was paranoid about is I grew up in a Porsche family. My dad was a fighter pilot. He used to ring Porsches out at the limit. I was deathly afraid of trailing throttle oversteer.
Okay.
And so all the way through the program, everything we could think of that might have anything to do with that, to make the car handle benignly, we did. And that involved everything from suspension geometry, tire construction. Very important to have very stiff body interfaces at the control arm attachments is. So those static stiffnesses, not just global stiffness, very important. So all the way through, we were figuring out what is every little design variable that would make the car not have kind of a two-stage feel or feel like it's going to get away from you. And then when we finally got into the first prototypes and started throwing them around, we were really impressed with how planted the back end felt. Even with 60% of the weight on the back, it felt really, really planted. And I know there's some articles out there, people have been in the car, some people say the car understeers. The people who have said that, they were driving at the limit with street alignments. We've since shown people, when you set up like you're going to drive it on the track, it's actually fairly neutral, but very, very stable, very easy to drive. Even people who aren't, our best track drivers, we let them go out on the track occasionally. They feel super confident, super comfortable in the car, right up to the limit. I think over the long term, as people start to live with the car and really experience it, that's something they're going to really appreciate.
Yeah, I got a little bit of a chance to drive one about a month ago or so, and while I didn't get a chance to really ring it out, it was out on public roads. Just what you were saying, instantly you just feel so connected with it. It just feels instantly comfortable. I didn't feel like there was any learning curve to try to figure the car out.
It's super responsive without feeling twitchy. That, if I can describe it that way. It turns in, boom, but it never does anything unexpected. All the responses seem very linear.
So on a given track, when you send out your real hot shoes on it, how much faster is the C8 than the C7?
Depends on the track.
Well, of course it does. But let's say just any given track, would it be a second faster?
It would be a second faster on a minute plus lap. So Z51 to Z51, which doesn't sound like a lot, but it's
a second's a lot.
Second's a lot. And actually, because the architecture is so capable, we're not leaning on the tires quite as hard as we have. We pushed tire performance to a pretty extreme level, trying to make the old architecture perform up to the best levels we wanted to. And so we're using practically race rubber on these. And so we had things like tire chatter, or the tires would fall off at low temperatures. We've actually walked that back a little bit to use a little more conservative construction and compounds in the tires. So it's a more well-rounded car, and we're leaning on the architecture part of it to make it a better car.
So explain to people who are not familiar with the difference between the C7 and the C8. I mean, so everyone knows mid-engine architecture versus having the engine in the front, right? And when you say that there's a second difference between apples to apples, basically, what is the cause of that? What allows that to happen?
It gets back to traction. Powering out of a corner. That's where you make up time on a race course. The sooner you can get on the gas, the entire straightaway you're going faster. So if you can just get that little advantage where you're not going to spin up that inside tire, or the back end's not going to come out on you, if you're really planted, you can get on the gas the entire straightaway. You're just going a little bit faster all the way down. And so that's where the advantage comes from. And the fact that we have 60% on the weight helps with that. It also makes our electronic limited slip differential, which you get on Z51, even more effective. It has more authority on the vehicle dynamics because it has more normal force to work with.
You talk about kind of the exotic segment here, Porsche, Lamborghini, Ferrari, all those great brands. I bet you probably when you were benchmarking the field, you thought, hey, there's opportunity here. Something we could do as Corvette, is Chevy. I mean, what did you see when you were looking at that field?
We did benchmark those cars. We always benchmark Porsche. Porsche's a great mark. They're like us, good bandwidth. You can do a lot of things, very comfortable everyday car, decent utility, very fun to drive, very track capable, you know, so we're constantly looking at Porsche. For this one, we took a heavier look at Ferrari. Now, obviously, Ferrari is at a higher performance level, but in terms of the fundamentals around the architecture, we want to make sure we understood all those lessons because we had to get it right the first time we tried it. You know, it wasn't like we're going to have 7 life cycles to learn and develop and make mistakes and correct them in the next generation. We had to get it right from the very first time. So we actually tore down those cars, tore down a Ferrari, and looked at every single part, measured it in every way we could think of, and then tried to do that and more into this architecture to make it as good as possible. It's one of the huge, you were asking me about the big challenges. One of the big challenges is we put the engine in the back, all the accessory drives on the front of the engine, which when the engine's in the front, it's as far away from you as possible. And there's a big engine in front of dash and everything between you and the accessory drive. You don't want to hear the accessory drive. It makes a lot of high frequency worry noises. That's not what you want to hear. And now you've put all that machinery right, 12 inches from your ear. And so one of the puzzles we were trying to figure out was how do we have a car that sounds good? You want to hear the intake, you want to hear the exhaust. Well, the intake breathes out of the back of the engine, the exhaust goes out of the back engine. We just put those things farther away, and you don't want to hear the high frequency stuff. We put that closer. So what are the architectural secrets of making it the good sounds audible and the bad sounds distant? And so one thing we were shocked at, you're asking, what did we learn? We took apart this Ferrari, a lot of the parts are very lightweight, but the back window was really thick glass. And we thought, well, we knew we were going to have to do that. We didn't realize how much we were going to have to do it. I mean, the back window on our car ended up almost 9 millimeters laminated glass. So it's like twice as thick as a windshield.
Wow.
Back there. And the reason is it's one of the primary sound paths between you and that high frequency noise. So we started with thick glass. We're using actually heavier than normal fiberglass around that glass. We're using acoustic on both the clean side and dirty side to try to create this barrier between you and all that high frequency noise. And then we had to use some very clever solutions to actually plumb the good noise around towards your ear, around that barrier, that sound barrier. And that's why the side intakes you see, the top third of that, that's actually the intake for the engine. So the throttle's on the back. We go through a big air box, comes around the sides, and we actually use the body structural panels as the ducting to get to the top of that side inlet. And so it's breathing. You hear those intake sounds, and it's nice throaty intake sounds coming right through that quarter. And so that bypasses that opaque barrier and gets you close to the thin side glass. That's very thin, relatively speaking, thinner than a windshield, way thinner than the backlight, so you can hear that.
That's amazing how you had to balance all this stuff. That must have taken a lot of acoustical experimentation, I guess.
Experimentation and the computer tools, the CAD tools are so much better now. I mean, that's one thing that actually enabled us to do this car, is a constant evolution of our computer simulation tools to try to do those experiments in math in a virtual world instead of doing it in a physical world. But we did end up building, we had to get this right. So computers are great, but we wouldn't bet the car that they're right. So we ended up building a series of mules, different iterations, to play with the constructions, play with the materials, try to get the balance right. And it did take quite a while, longer than the normal gestation period for a typical car.
Because it's just such a different approach to
It's
how
so
you run the
different,
car.
so new. And I tell people, when we revealed the C7, we were already working on this. We were already thinking about this. So it's weird to be revealing and loving that car. I mean, we did a great job, everything we could possibly do for that car. But in the back of our mind, we got this thing on the back burner and starting to pull it towards the front burner.
Okay, so you brought that up. I'm going to put you on the spot here because you were last on this show in March of 2015. And we asked you about a mid-engine Corvette. And Katie, can you pull up that clip? Here's what you had to say.
That car doesn't exist.
Yeah.
I know
yeah,
no
we were
such
asking
car. Play your
about it.
question. You got to play your question because I remember your question.
Yeah. So, we didn't get the audio. Anyway,
I know no such car exists.
yeah, and you were talking about a mid-engine
I was
Corvette.
talking about the physical car. You were talking about a physical car on the road, and that was true. There was no physical car on the road.
Okay,
That's
so-
when we were doing our virtual
Okay,
work.
so now I'm going to ask you, what about an all-electric Corvette?
Well, I can't talk about anything
Future
about the
product.
future product. I'm not going to go into that.
Okay.
But, you know, Corvette is part of General Motors, and part of General Motors' mission, you know, from the top of the company, 000. So zero emissions is part of our mission. Now, that's, you know, a future state. We'll get there eventually. So that's our job, is to continue to work towards that.
With the C8, though, a lot of cities in Europe are saying, hey, this is an EV-only zone. If you go into the city center, you cannot be... What about doing some sort of battery thing for this, for those?
Now you're asking about...
Okay, now I'm
future
asking
product.
about future product.
Yeah.
You guys are aware of this, obviously. Though.
Obviously,
Yeah,
the regulatory environment around the world, as well as our own mission and our own belief in preserving the planet, leads us to believe that electrification is coming. The question is how fast, how do you do it? That's part of our job.
So let me ask you, you mentioned, John mentioned Europe. Okay, you're going to have a right-hand drive version of this car.
Super proud to be doing that.
And
First time ever, right?
First time ever.
I wasn't aware of that.
Yeah, and so,
We've looked at it before, it was never affordable.
I mean, what were the challenges of doing that? I mean, because the way the cockpit is designed with the, you know, it sweeps around the
Very
driver.
deceptive
I
of
mean,
you.
it's,
So the good thing we did was move the engine in the back. So not having that in the way and being able to translate everything over and not having to worry about all the plumbing in the engine, mid-engine actually made it inherently a little bit simpler on the outside of the car. But you bring up, you know, Corvettes historically have had relatively expressive interiors, driver focused, cockpit. And if you look at most people who do left and right-hand drive, they're very planar interiors. That makes it easier. The door trims can be the same. The IP is perfectly symmetrical. Well, you've seen how, you know, bespoke ours looks. And so we had to come up with some very clever ways, honestly, some clever tooling solutions, because it's going to be relatively low volume. There's relatively few markets. It's new for us. We never sold a car in Australia. We know we have passionate fans there, but we really don't have a great sense of what the volume's going to be. So we had to look at new ways of tooling parts to do the exact part that looks like it, but a mirror image of it, to get to the right-hand drive and do it at a reasonable business case.
Wow.
So we're taking a little bit of a bet there. You know,
Yeah.
we have people come to Corvette events from Australia,
But you got to be looking
you
beyond
got
Australia.
Japan, you got your
Japan, which we
England,
sell in okay.
the UK.
UK we don't sell a lot, but I think our volume will go up there
Yeah.
doing a
South
real right-hand
Africa.
drive.
That's also pretty
Going
dinky.
to South
Right, yeah.
Africa is too small
Yeah.
at this point. But we're dipping our toe in the water for right-hand drive, and we'll see how it goes. Hopefully it'll take off.
So while we're in that space, the steering wheel has an interesting shape to it that is not commonly found in cars. I mean, why did you go for a more squared off steering wheel?
Interesting story. I've always believed that wheels should be round. You know, I'm kind of old school that way. It was our first step of making a flat bottom wheel. I wasn't a huge fan of, but we did it on the 7th generation. And we did some rapid prototype wheels, and we were driving around, kind of getting used to it, because the way I drive, I want to know exactly where the rim is when I go for it. I want to be able to let it slide through my fingers and be able to control that very well. But we found the flat bottom wheel was well accepted by customers. It was easy to get used to. And so we knew we were going to do a fully reconfigurable display on this car. And so design said, well, why don't we square it up? Let's, you know, instead of blocking, you look at some even very well-known manufacturers, they do these reconfigurable displays, but a lot of the reconfigurable part is actually behind the steering wheel rim, and you can't see the information that's there. We didn't want to do that, so we said, well, you know, we call it squircles, you know, square up the corners and make a, you know, rounded square wheel that's also offset to have a small diameter wheel, which is very sporty, but still leave a lot of visible area above the hub. And so we started playing with shapes, and same thing, we did rapid prototypes, we drove them around, saw how hard it was to get used to, and I eventually became a believer that it was a good trade-off. So straight down the road you can see everything, and you kind of get used to the corners almost as a handhold. You reach for it and you know where it is. And it gives you a really nice 10 and 2 and a 9 and 3 hand position without the spoke being in the way. It's 2-spoke wheel. And if you look at the shape of the wheel, we have comfortable places for people who prefer either position. So that's a little bit of an experiment. We'll see how the customer reaction to it. I'd say the media reaction so far has been pretty good. I actually thought the media, some of whom can be conservative and just, no, why would you do that? Most people have agreed that you get used to it pretty quickly.
Mm-hmm.
All right, we're back talking about the C8 with Tadge Junctor. And Greg, you got the floor.
Thanks. I'm pretty psyched because this mid-engine Corvette is so just anticipated. People have been talking about it for years. What I'm curious about is, does this sort of like fundamentally change who the Corvette buyer is?
That's an interesting question, and one we pose to ourselves all the way along. You're right about it being so anticipated. We couldn't allow ourselves to think about that. The pressure of having to do it and do it right would just be too much. So we just kind of had to put our heads down and not think about that, just do the best car we could. But it's true. I mean, the reason we went mid-engine is a physics-based reason. It's a bad business strategy to bring out a new Corvette that has lower performance than the old one, or even equal performance. It's a performance car, so people are looking to expand the edge of the performance envelope. And I've told the story, I mean, we knew we were reaching that limit, that we just couldn't get power to the ground effectively enough. We looked at ways to shift more weight bias rearward, and it gets kind of crazy, some of the stuff you have to do, and you can only make very small percentage changes. So we kind of knew we had to make a fundamental shift, and this was the right time, do it a bunch of different elements. But we also had some pretty good data. We don't do clinics on Corvette, because if we did, everybody would know it's a Corvette. You can't fool anybody. And so that you'd be telegraphing, and everybody, because when you do a clinic, you bring a representative slice of the population, and we have a big part of the sports car market. You'd have a bunch of Corvette people saying, we're looking at the new Corvette, and then it would just get right out there. So we don't do clinics, but we do have pretty good information that says our current customers are pretty happy either way. You'll have a few naysayers here and there, just like when we went away from round taillights. You'll have a few people saying, I don't know, that's not really a Corvette to me. But most of our customers that we talked to said, I could go either way. If it's a better car, that's fine. But people who don't consider a Corvette today, it was vastly different. It was like 90-10. Would prefer a mid-engine architecture, and also those folks skewed younger. So we're not walking away from our current customers. We love our current customers and want to do a car for them that they'll be happy with. But at the same time, you can't have your demographics continue to get older every year, or eventually you won't have any customers. So there's a demographic reason to do it, a physics reason to do it, and so we're really lucky that both the business rationale and the physics rationale lined up to do it.
Tadge, let me ask you a question about the development of this vehicle. So you don't do clinics. Do you have an engineering team that has always worked on Corvettes, or are these people who are working in other car programs and you get them as you need them?
It's a mix. Of course, when you start doing a new Corvette, you need a lot more resource than when you're sort of in a maintenance program after you've got the major model launch. We do follow-on models typically, so you typically have people, but when you're doing an all-new car, that's when you need your largest staffing. So we're part of General Motors, and so we pull resources from various parts of the organization. Very few of them report directly to me. They report indirectly to me while they're working on Corvette. And we have a lot of people that self-select. So anytime there's something going on in Corvette, they'll raise their hand and say, me, I want to be on the team. And so we have a lot of people that, even though they technically don't work for us, they've been on the programs for 5, 10, 15 years. And so they have a long history with us. And then they self-select, and then we also select people we like a lot. Mm-hmm. We encourage to come back when we need them, and people we really like a lot, we try to keep all the time, keep on the program all the time.
So there's consistent tribal knowledge of what a Corvette is and what it should be.
Core group of people, I've been on it for 26 years, since 1993, and working on the C5. And there's quite a number of us who have, a decade or more of experience. And you need the tribal knowledge because it's such a distinct car. I mean, not just that it's a 2-passenger car, but it's a composite intensive car. It's an aluminum body structure car. The way it goes together, the way it's built is completely unique. So we do things differently. A lot of things that you wouldn't think would need to be different are different on Corvette. Things like antennas. You see no visible antennas on a Corvette. Our customers wouldn't like it, but also they don't work. A typical antenna needs a conductive material to sit on. You stick all the shark fin things that you see on everybody else's car. On our car, it doesn't work. So we have the disadvantages. Our body panels are not conductive, so it doesn't have a base plane for the antenna to receive anything. The advantages, our body panels are transparent, and we can put different antenna solutions under the skin so you don't have to look at them.
How closely did you work with Corvette Racing, or vice versa? How closely did they work with you? I'm sure they said, by the way, as long as you're going mid-engine.
Well, we've been developing a relationship with Corvette Racing for years and probably are the benchmark for collaboration. It was very, very close on this car. I was mentioning the thermal challenges. They helped with a lot of that thermal modeling, a lot of the vehicle dynamics, weight distribution for optimal performance. They helped us out. And then we were in parallel developing the race car too. So there was a lot of give and take on what would make the street car the best possible starting point for the race car, because a lot of the hard points they have to hold on the race car, and they wanted to make sure the race car was as competitive as it could be. And so we're super close to the race team. We have joint meetings all the time talking about various aspects of the vehicle design. It's almost like one team at this point. You know, I have a bunch of their engineers on speed dial on my phone. I'm going to the Pratt & Miller Christmas party this Saturday. You know, it's like we're family now.
Yeah, yeah. They must be super excited.
They're very excited, and they're looking very much forward to Daytona.
Yeah, we're just
in January.
Yeah, a month away or
very
so.
Close,
right.
to getting the C8R out and on the track.
Way cool.
How many customers do you think will track the car, I mean your car, that car, versus daily driving?
It's a really good question. I don't know if the percentage will be any different than historically. The track driving gets a lot of internet discussion. My best knowledge is only like 5% of people would actually track the car with any regularity. Now, some people do club events where they'll go with a club and they'll rent a track and they'll go out there and drive it on the track, but they're not really hammering 10/10ths and really trying to wring the car out. It's just fun to drive on a track. And so that sort of hardcore people, it's really actually quite a small percentage.
I'm kind of curious how you kept this program a secret as long as you did.
Secret?
Maybe it's for the hiding in plain sight.
It felt like it was on the cover of every magazine for the entire time we were developing it. And that was actually one thing we knew right from the beginning, is we weren't going to be able to keep it a secret. You can't test the car and hide its proportions. We talked about it early on, could you stick a big artificial nose on the thing? You know, we talked about these, and you saw the Holden Ute, one of our very first mules. That was the only way we could think of making it at least questionable what it was. But we knew early on that we're not going to be able to hide the proportions, so they would know General Motors was working on a mid-engine car. And we've gotten to the point where it's such a high-performance car, the aero is so important that we have to have very lean camo towards the end of the program. So basically the tape camo, and you know, everybody's gotten so good at peeling that off digitally and doing renderings. We knew by the time we revealed the car that people would pretty much know what it looked like. But that wasn't really the big story. What it looked like, you know, we could have done it a bunch of different ways. We're glad at the reception the car has got. But the story is so much bigger than just what it looks like, especially just the exterior. The interior, I think, was a big surprise to people.
Yeah, I'm glad you mentioned that Holden Ute, because Mr. Car Guy 20 wrote in to say, ask Tadge about that.
Okay.
But we got a number of questions from Don Sherman, who you know and knows a lot about Corvette. A couple of interesting ones I hear. He wants to know, why is the C8 heavier and why does it have a higher center of gravity?
Okay, there's a very long answer to that question, a few long answers. So we'll start with vehicle mass. The biggest reason is the transaxle. So instead of having a manual 7-speed, you have an 8-speed DCT. DCTs are pretty heavy. all the cooling requirements for DCTs, they operate in a narrow range of temperature, optimal temperature, because you have friction clutches, and you don't want them to get too hot or you lose control over those clutches. So there's quite a lot of cooling that goes along with it. I would also say things like, and it's also related to his other question, is CG. We got away from our transverse composite springs and are using traditional coils now. That was required because of the packaging. The engine and trans are so low, the sumps are right on the ground line. There's no place to do a transverse spring. So we had to do coilovers, which mean you have these big steel coils, which are much heavier than those composite springs, and people have been complaining or critical of those for years and years, since C4. But they were a hell of a deal mass-wise and packaging-wise. So you not only have these big steel springs that are up high, you have all the structure, big, heavy aluminum casting to react those loads, also up high. So that's part of the vehicle mass and the CG. We also learned in doing this car, this is the stiffest, now I'm going to talk about global stiffness, not the local stiffnesses for suspension attachments. The load pass for the body structure for an open car, so all our cars are convertible, you can take the roof out. This needed to be the stiffest car we ever did, so that drives mass up. We have a bunch of new crash requirements, and the fundamental load paths are a little bit less efficient on a mid-engine car than on a front-engine car. Just the way the corners they have to go around, the way your pedal box sits right up against the front tire steers, you can't squeeze much structure through there. So you're more dependent on the structural tunnel for mass. Even though we do take advantage of the rockers to some extent, if you look at it, there's here and there's little inefficiencies that we try to make up with high-pressure die castings as best we can, the most premium structure we can, but a lot of little things contribute to some additional mass.
And I would say, who cares if it's faster?
It has a lot of content, new features. It could go on and on. I was talking about the acoustics, needing to make the accessory drive quiet, that thick glass in the back, that's heavy. All the thermal stuff is heavy, a lot more shielding in the back end. Goes on and on and on. I honestly thought, this is going to be a breeze, because look, you're taking out the whole driveline assembly from front to rear. You're taking around 6 feet of exhaust pipe out. And I thought, oh man, this thing's going to be so light. But no, the other factors more than offset those eliminations.
Just a quick question about the glass. In the convertible version, are you using 9mm thick glass back there as well?
It's thinner on the convertible because there's another panel between you and the engine. The convertible has a big thermal metallic panel underneath the folded top, or when the tonneau is down, you have that panel plus the tonneau between the engine and that glass. So that's actually more of a conventional thickness glass. And that's independently controllable. That's one cool thing about the convertible is if you want the top up, but you want a little more exhaust sound or you want a little more ventilation through the interior, you can independently put that thing up or down, whether the top's up or down.
Are there any Easter eggs on the car? I know like Jeep and Viper used to be great at having little hidden things in the car. Anything we should be looking for as we put some miles on these things that you could tell? Or just
well, then it wouldn't be an Easter egg.
Don't give it away. Just
there's a few
say
odds
that
in
there's
it.
some out there.
We'll see when people get their cars and they start to play, they'll start noticing a few things.
So you mentioned the rockers. One of the things I noticed is that compared to other cars of a similar configuration, this is very easy to get in and out of.
That was important to us, keep a low sill. Other people use a tub construction, especially if they're going to do an open air version. If you make those rockers tall, you get good structural properties out of them, but it makes it harder to get in and out of. So the height of our sill is the same. It's carryover from today. It's a tiny bit wider because the occupants scooch inboard just 20mm, not a lot, but we do that to line everything up. I was talking about the pedal box. We want to make sure the pedal box was straight ahead, dead pedal exactly in the right spot. And to do that, because you're basically sitting on the front axle, you have to move the occupants in just a little bit. So that's one we were talking about early architectural learnings. That was one thing we were playing around with the big dimensions on the car. That was one thing we had to decide to do early, was bring it in just a little bit.
What other engines maybe did you guys consider using in this? I know This is definitely one that everybody is, very much a fan of, but did you consider any other options?
We polled our customers at every single customer event how much they would like a 4-cylinder or a 6-cylinder,
Yeah.
and we were roundly booed.
Okay.
At that suggestion. It's pretty unanimous that the small block be, that it's, if you're changing everything else about the car radically, having that touchstone, that bit of familiarity, as well as, honestly, the packaging size and the output of that engine, if you look around that engine compartment, one of the main reasons it makes more power is because we can use the extra space in the back because the rear wheels don't steer. So there's actually extra space for very efficient plumbing on both intake and exhaust. So big air passages, no places where you have to pinch it like you have to do on a front engine car. And so the engine naturally breathes better, and that let us put a more aggressive cam in it. And so that's how we get more power. So anyway, it seemed like actually quite a good fit because, yeah, I didn't talk about this, but there's other structural load paths, especially for a convertible. If you see these big aluminum diagonal braces reaching out to the top of those very high shock towers I was talking about, having a compact engine lets us put very large structural elements in there. Lots of space for efficient structure.
And that's one thing about those pushrod engines. They're pretty compact.
It's amazing. You think about these, you look at other people's engine displays, and they might smaller displacement, but you look at the exterior dimensions, they're pretty big.
Alexander Karabitsis wrote in, and I'm glad he asked this. General Motors had trademarked the Zora name. Zora Arkus Duntov, of course, being the one who really pushed the Corvette to happen. Or is there anything going to be done with that name? Is that, or am I getting into future product stuff again?
All I will say is that if you look at that time period when we trademarked that, we did a lot of cleanup. We wanted to make sure we had ownership for things that we've used historically. We knew that Zora was going to play a big role. When we introduced this car, everybody would look back. We knew we'd talk about our history, that this isn't a newfangled idea. This was, from the 60s. Zora started this. So we knew we would play up that history. Wanted to make sure we had access to the things that we're talking about. If you look back in that time frame, you'll see we took everything we thought might have Corvette relevance and trademarked it.
Oh.
Zora was one of those.
Gotcha.
When this car was
From the family, by the way.
when this car was first introduced in California and the big event, the audience went wild when it was pointed out that there's the ability for the vehicle to be raised so that you could not necessarily scratch the front,
Scrape the nose,
and that it's something that is learnable by the.
Yes.
By the, can you talk about that? I mean, it was just clearly something that people were really excited about.
Well, that's an example of something that happens when you know your customers really well. And also, many of us on the team are customers. We're enthusiasts too, so we buy Corvettes with some regularity. But, that's been a historical challenge, having a car that's inherently low. You want a low center of gravity. It's low and wide and it's pointy, so the chin sticks way out there for aero. You really want to have that. And plus the tire deflectors and the rubber parts under the car, they scrape on the ground. We wanted to try to do a better job, in part because we wanted the whole experience around the car to be more sophisticated. You weren't dragging your nose of the car on the ground all the time isn't something you really want to do. And we also, back to the new customers question, there might be people, Corvettes have dragged on the ground forever, but if you're bringing in a new customer, they might be coming out of a car that doesn't drag, and they're not going to forgive that. So we wanted to solve the problem that customers had been experiencing all this time and make it better for people who are new to the brand. Now, here's another example of it was very difficult to do this. We always wanted to do this, but with a transverse composite spring, it was very difficult to figure out a mechanism to pick the car up. With a coil spring, it sits in a big seat, and all we have to do is put a little hydraulic spacer in there that pushes down on the spring and then effectively lifts the whole car. So the mechanization became much easier with this architecture, and so we said, we got to do this. And then we came up with the idea of, well, why don't we, practically every car has GPS on it, why wouldn't we make this GPS enabled? And so 1,000 points you can remember, and It's a really nice, it's an elegant execution. Anytime you say lift here, it'll say, do you want to remember this one forever? And so you hit the one left switch on the right side of the steering wheel, it'll remember that forever, and you can remember 1,000 points. And so it turned it into kind of a no-brainer, and it's smart enough to know if you're coming in hot, you're distracted, you're on the phone or whatever, you're coming in too fast to something you know how to program, you're not thinking about it, it'll start lifting the nose earlier to make sure it's up before you get there.
It's really cool. All right, we're back with Tadge Juchter talking all about the C8 Corvette. Jonathan Brown wrote in, he wants to know, did you put this through GM's 300,000 mile validation process? And he wants to know, why did you go with the central backbone chassis? Can you explain why you went that way?
Okay, well, those are two very different questions.
Yeah.
We've been talking about structure, so I'll elaborate on the backbone. So when you don't have a roof in the car, the roof is a very efficient structural member to react torsional. So when you hit a bump with one wheel, that's what you're doing, is you're trying to twist the body. And you need that very stiff resistance to make sure the chassis is what deflects, not the body. The body deflects, it's a undamped spring, essentially, and you sort of lose control over the loads at the tire patch. Makes the car handle badly, and the driver feel insecure. So that's why I want to make sure the car is very, very stiff. No roof. Now you got to find some structural elements to react that load. And for the last, really since the 5th generation, we've used a structural backbone. So that's a very large center tunnel section that's closed out on all sides, so including the bottom. There's a whole bunch of fasteners and a structural plate, like 5 millimeter thick aluminum plate on the bottom that gives us a flat floor and a completely enclosed box. Having a DCT only, I know a lot of people are upset, including myself, about not having a manual, means that box, since we have electronic shifting, is completely closed, no holes in it. And that makes for a very stiff structural member. So lightweight, stiff, that's what we want for an open car. So we kept that strategy from the prior generations, actually works really good on this one, and keeps the sills low, which we were talking about earlier. You want to make sure the car's not a hassle to get in and out of all the time. So in terms of the durability question, yes, we do all the durability of General Motors standards for all the cars. Now there's some things like that we use on truck durability that this car cannot do. It'll get stuck. Going over some of the obstacles that they go over. So we amend it to what this vehicle is capable of. But in terms of mileage and durability and corrosion and all those things, we meet all the GM standards. And if we took a typical customer on our test roads, they would say, I would never do this to my Corvette. I would never put it through this. I would turn around and find another way, but we just hammer on. We have durability drivers going on these really rough roads and potholes and twist ditches and corrosion grit troughs and all this stuff. We put it through the whole paces.
Do you ever see a future with all-wheel drive for the Corvette?
Having 60% of the weight on the rear almost feels like all-wheel drive.
Yeah.
It's amazing how much traction the car has. We have had some customers say they would like to have all-wheel drive, so it's always kind of, in our process, maybe someday it'd be nice to, but I'd be curious to see when we get this one out there if that all-wheel drive noise quiets down. They think, you know what, this car has so much traction, I don't know if I need any more. I don't need that extra weight and complexity, so we'll see.
You mentioned the transmission. Tell us about why this does not have a manual transmission.
A lot of different reasons. The biggest one is commercial. It has to be.
Nobody buys them.
Nobody buys them, and no one's willing to make them at a loss for us.
There's the answer.
Yeah. It's hard enough to find somebody to make a bespoke high volume, because the vast majority of people choose the automatic. We used to offer the Z06, the R1 only in manual transmission. As soon as we made the automatic available, 70, 80% of the volume. And so it's personally crushing to me. Mm-hmm. I have never purchased a car in my entire life for myself that wasn't a manual.
See, this is saying something. When the executive chief engineer wants a manual and the car doesn't have one, and I'm like you, I prefer to have a manual.
There was a lot of crying in our office when we finally had to make the decision that, it's just not going to work. And we even looked at, I think Don Sherman even suggested it, do a synthetic manual, do an electronic simulation of a shifter and just operate the clutches.
I don't want that.
It would be a bad manual and it'd be a fake manual. But yeah, first of all, we couldn't find anybody to build us a transmission. Second of all, it would have been a lousy manual transmission. It's very difficult to get, you want a slick shifting manual. Now we have an engine between your shifter and the transmission, which means you can't use mechanical linkages. This has to be a cable, which makes it kind of rubbery and vague. Other people who do it like Porsche, they have a flat engine. We have a V engine. There's not a great path for cables to go through to get back to the transmission. So it would not only be a cable shifter, but it would be a kind of a lousy cable shifter. And I was talking before about how it would have compromised the interior, the architecture, because we'd have to punch holes in the center tunnel. I was talking about the pedal box before, having to put a third pedal and a dead pedal, so 4 pedals up there pinches the body structure. That tight space I was talking about between the steering front wheels, getting around to the rockers, having to put another pedal in there, squeezes that structure down, makes it even less efficient. So now we're hurting the whole car to do it, and since we couldn't even get somebody to make one for us anyway, we eventually had, you know what we're going to do? You can see manual transmissions are on their way out. Nobody's going to make them someday. Why don't we optimize the car around a really great DCT and make it as manually engaging as we can. So we put a lot of features in there that make it fun to control, like dual pedal neutral. So my typical manual driving style is I like to coast. I look at traffic ahead and I'll pop it into neutral and coast. Now you can do that in this car, just double pedal neutral it and you coast in different situations. So if you want to have a little more engaging driving experience than sort of the typical paddles, we've got that.
And you have different settings for the vehicle as you're driving it, so it changes the response.
The modes,
throttle,
yes.
and the
We've never had
transmission.
more modes than we have now. I mean, it's a weather, tour, sport, track, my mode, Z mode. If you can't find a mode you like, it's a problem. And 2 of those are customizable, and almost everything about the car, you're talking about shift quality, that's customizable. Both shift points, shift firmness, how crisp the shifts are, those vary by mode, and you can independently select them for the Z mode or the my mode. So it's very, very customizable driving experience.
Hey, we got a phone call here, the control room tells me. Let's bring in that one from John about the brakes.
Hello, John, and thank you very much for putting the show on, and Tadge for bringing the Corvette. This is John from North Carolina. I have a question on the flywheel. Looks like it's some type of dual mass flywheel. I'm assuming for the V8 and 4, maybe some type of dampener, but I just wonder if you could elaborate on that. And also on the electronic brakes or the electric modulated brakes on different modes of the braking as you can go up through the different modes for driving. Thank you, Tadge, again. This is awesome. John from North Carolina. Bye.
Thanks.
Okay, well, somebody's been studying. If they've noticed what we call a CPA, so that's the damper between the engine and the transmission. That's there it's there for a couple of reasons. I think he's very perceptive that when you have an engine that does V8 and V4, vibration can be a challenge, and dampening those resonances is very important. So that's part of it. And this car we're very proud of, because that was one question we didn't honestly know, is a DCT is like a manual transmission. And manual transmissions we're the only ones who ever try to do cylinder deactivation in a traditional manual. And if you've been in the car, it's perceptible. You can tell when it's going V8, V4. And we wanted to try to do a better job for that. And so that required invention, honestly. When you're in V4 in this car, we take those DCT clutches and we slip them very, very slowly, like 25 RPM, which is crawling compared to engine speed, but they're just slipping ever so slightly to kind of act like a friction damper between the engine and the trans. The damper he's talking about helps us out with that. He's talking about the brakes. So most manufacturers with direct injection engines, you don't have a lot of vacuum available. Most manufacturers are headed towards an e-brake system of one kind or another. It's got its advantages and disadvantages. One of the advantages, you can tailor the braking reaction, the gain of the brake system. And so we've added that for the first time in our menu of things that you can adjust. So we try to have like the touring mode be kind of a relaxed braking situation where it's very easy to modulate at low pressures. And then in sport, you want a little stronger bite, like you're more likely you're going to be looking for more decel for a given amount of pedal input, make it feel like the brakes are stronger for a sportier driving experience. So that's the kinds of things you can change with what we call e-boost.
Mm-hmm.
When you look at the materials that you used for this car, I know there's a variety of ways you can make cars lighter and more sophisticated. Just kind of like, how did you arrive at the ones you selected for the new one?
Well, Corvette's always been a mosaic of materials. People
Yeah.
think, oh, it's fiberglass. Well, it's not fiberglass. Fiberglass is a whole range of composites, and we use everything from pure glass-based to carbon fiber. And so in some places, mixes of that. And so we try to let the part tell us what the material should be. Some people make a top-down decision. This is going to be aluminum car. We're going to do everything in aluminum because I want to do an aluminum car, and I'm going to mandate from top down. Instead, we use criteria around how much is mass worth to our customers in terms of performance and fuel economy and everything else. So we put a big bounty on mass, and then we let each engineer work to figure out what's the right material for each part, given all its other requirements, because every part on the car has massive numbers of requirements. And so that's why you see quite a variety. You know, we've kept aluminum in the base structure. It's very good for energy absorption, so the big crash tests that we have to do, front, rear, side, you want to have a material that's very reliable in the way it crushes and absorbs energy. Composites can do that, but it's more challenging. It's good having a metallic substructure because you want a conductive material for all the grounds that you need for your electrical system. Some super exotics don't do that, and so you'll find they don't have some pretty basic features on the car because they don't have reliable ground strategies. So there's a lot of things you don't think of necessarily as to why the parts are the way they are. I will say around our metallic structure, we made a big evolution. We learned a lot about aluminum structures on the 7th generation car. We applied all that to this one, much more dimensionally accurate, less welding than ever because welding actually distorts the part and changes the material properties. So much more structural adhesive with redundant mechanical fasteners, so screwed and glued, we call it.
There's a technical term for you.
Yeah. And then, you know, the rest of the car is bonded and bolted together. It's built a lot like a race car where we take other composites. If you peeled off the bodywork, you'll see all the dark colored panels underneath. Those are mixes of glass and carbon and other materials to be structurally robust, but they're not Class A capable. You know, they're not able to be painted with very high finish quality. And so we have different materials on the outside of the car that can hold paint and live up to a very high gloss standard and also meet the dimensional controls that are required.
It's interesting. I know GM is rolling out an all-new electrical architecture for, like, you know, the infotainment, all just the things that make the car work. What kind of benefits did you guys get from that for your car? Because I know it's the mid-engine Vet and then like the Cadillac CT5, I think, are among the first that are going to get this. What did you guys take from it?
And we decided early on if General Motors was going to do electric architecture, we wanted to be on board.
Yeah.
Because if you're not, you fall behind in terms of features and new things that happen. The main benefits to us is much faster communications, onboard communications. Cybersecurity, you know, everybody is faced with this. Here's a car that has tremendous authority. Everything's electronically controlled. You can imagine if somebody got in with bad intentions, what they could do with the car. So we really have to protect the car from any outside interference. So cybersecurity is going to become more and more and more of a concern. So we obviously wanted to be on board with that. And then over-the-air software updates, you know, kind of everybody's headed for that. So this is the first architecture where we're going to be able to do that to any degree and scale. And since so much of the stuff is electronically controlled, it's also able to be continuously improved. So we're able to offer that to customers. You know, the car will evolve in a positive way over time because of what we learn software-wise.
I would think OTA would have a lot of benefits for the Corvette in particular, just because, you know, the car has such a long life cycle. You know, the generations, you know, go on with some.
Typically do. And so, yeah, we don't want to be left out from a feature functionality standpoint, and those learnings, being able to continuously update those for customers is a big deal for us.
You know, we've mentioned this is a mid-engine car, and the thing we haven't talked about is the seating position, how different that is. Could you talk about that?
Well, the whole occupant compartment's about 16.5 inches farther forward. I mentioned earlier, almost riding the front axle. I mean,
And that changes your perception in the car. It feels like it's turning faster, right? Because you're that much closer to the front axle.
Yeah, we use the analogy, it's like being in a jet fighter where you're in the nose of the cockpit rather than the locomotive where you're sitting in the back. It's not that extreme, obviously, but you do go from sitting well behind the center of gravity of the car to a little bit forward of the center of gravity. Your personal center of gravity is a little bit forward of the center of gravity of the car, and that gives you a very different riding experience. So when you turn the wheel, you're moving physically in with the front end of the car that's rotating. You're not sitting behind the center of gravity, and so that you're actually moving the opposite way a little bit. So the front end turns, vehicle rotates around the center of gravity, and so the car's going this way, and you're actually sort of following around the corner that way. And anybody who's been in the car realizes that that's a real thing. It really changes the driving perception. You combine that with, you know, being able to see the road straight down in front of you, just past your toes. It's kind of an exotic driving experience.
Is this going to be perhaps the most like daily drivable exotic mid-engine car? Is that even a goal?
Well, I was mentioning bandwidth earlier. I think people are going to be really surprised because when they look at the looks, they think, oh my God, this is over-the-top exotic. It's going to be hot, uncomfortable, noisy. But when they get in it, they're not going to believe how refined, how easy it is to live with, how comfortable it is. It's like the best of all worlds.
Speaking of seating position, Dennis Morin wrote in to say, for the tall guys out there, how's the headroom compare to the C7?
We've tried to make accommodations for larger people. We know, you know, Corvettes are inherently small. You don't want to make the car gigantic so that the vast majority of people have to live with a bigger car than it has to be. But we also try to accommodate people as best as possible. And we've actually had some 7-footers sit in the car. I wouldn't say they're comfortable, but they did fit in. And there's we've met quite a number of people who couldn't get in a C7 and are buying this one. So I won't say anybody can fit, but 6'5", 6'6", pretty easy. We've extended the seat travel rearward a full inch, which helps you for two things. It's leg room, but it actually helps you with headroom a lot. Because we've also added 9 degrees of recline angle, which doesn't sound like a lot, but when you have that extra fore-aft dimension and recline angle, the tall people can kind of sit back behind. Some of our published dimensions don't show it because the way the sort of typical SAE type dimensions are 50th percentile standard measuring, not 98th percentile people, and the way they really put their seat. I think most people will find this car roomier from that perspective. And coupe and convertible are a little bit different. In some ways, the convertible actually has more room because it doesn't have the structural bar behind your head. But it depends on how you're seating position. In certain seating positions, it's a little better. In certain seating positions, it's a little worse. So I advise people try them both before you decide.
Go to your Chevrolet dealer.
Chevrolet store, when we start building them.
Hey, I was before the show, I was talking to a couple of guys from Bose, and they said, oh, if you got Tadge on, you got to ask them about the Bose system. So let's hear it.
Well, that was another big challenge. You know, we have this relatively large interior space on prior generations of car, lots of places to put volume for speakers, volume for other acoustics. Now we have this solid bulkhead that blocks noise from the back, so we actually had to integrate the speakers inside a smaller occupant compartment. Bose has been a partner with us since C4 at least. And they were on board early to try to figure this out, where the speaker placement, exactly, you know, how are we going to do this? We didn't want to walk away. In fact, we wanted to upgrade our acoustic performance from today's car, but we had to do it with less room. And so that was a technical challenge. We basically had to push stuff out of the way to put the speakers where they needed to be. We have a really clever solution in the doors. If you look at it looks like there's no woofer. We've had traditionally these 10-inch woofers in the door, which are very large for a small car. And we had these big mesh screens over them that people didn't like when they're on track. It's called the cheese grater. It's like the side of your leg. It's on this grill. We wanted to do something a little friendlier for people who drove on the track, but not lose any of the acoustics performance. And we came up with this ported design where the speaker sits horizontally but fires low. Low frequencies are not directional, so it doesn't really matter where they come from. You can still hear them. It's all about kind of acoustical power. And so we came up with this really clever way of making an invisible speaker port. If you lay on the ground and open the door, you can see a series of grates under there where it comes out. And it's turned out to be very effective. We use a very powerful amp, all the latest electronics. And Bose told us that this was the loudest system. In fact, they came to us and showed it to us, and they said we truncated the volume. And I said, oh, was it distorting? They said, no, we just truncated because we didn't think anybody would ever listen to it that loud. We said, no, don't truncate it. Let the customer turn the knob and truncate it if they choose
11.
to. Yeah, some people want it at 11. So it's the loudest system, and it's very clean. It sounds great. It's the loudest system Bose has ever done, the loudest system GM has ever done. It cranks.
Greg was mentioning daily driver, and you mentioned before that you have a trunk that things can actually go into. You also have a frunk in this car.
Yes, we put the heat exchangers outboard to try to make room for front because we really want. And most cars like this only have the front part. Like I said, the back is the engine and everything else goes in the front. We knew we couldn't put a roof in the front. There's just not enough room up there. Practically would have to have a two-piece roof. So we wanted to make maximum advantage of both. So we pushed the heat exchangers way to the outside. And our target was we wanted a standard airline rollerboard to fit. So that actually set the width of the rails, the front crash rails, to be able to fit that in. And then we tried to preserve that room as much as possible. There's actually room for a rollerboard plus some other stuff. We do sell some luggage, some really nice luggage that'll go with this car. And you can stack two of them, top and bottom in the front, and they'll go side by side in the rear and still have room left over. In fact, the C7, the prior luggage set, which was designed to fill the whole back end, it fits in this car too. Fully packed. So kind of volume-wise, it's broken up differently, but the volume is essentially carryover.
Do you think Corvette is, and always will be, perhaps like a one-car brand? Or do you ever see a day where Corvette kind of becomes like a multi-vehicle brand?
That notion has been around for a long, long time. And, it's been promoted by some, booed by others. Yeah. The Mach-E, Ford is obviously deciding to embrace that. It's a big challenge. If you talk to most of our current customers, most of them don't like the idea of diluting the Corvette brand. On the other hand, some people say, why don't you make an SUV? I have an SUV in my garage. I'd love it to have it, you guys design it. Yeah. So, that's always sort of out there. I can't talk about any future product. It's been in discussion, kind of in the media, probably more so than anywhere else for quite a long time. So it's an idea that could be leveraged at some point, but right now we're focused on let's get this car in production and make it as perfect as it can be.
Right.
How long did you actually work on this? Whether, from the very first glimmerings to the car we're seeing here?
It's tough to say, because when I first came to Corvette, working for Dave Hill in 1993, early in the development of the C5, we looked at a transverse North Star-based Corvette. We looked at package studies to take that, which was new, hot engine, had a transverse, transaxle, no manual. He came from Cadillac. He was interested in that. So you could say, okay, I worked on it then, 1993. I was obviously aware of Zora's work. I loved the four-rotor car early on as an impressionable young lad. But in terms of earnest work, we really started talking about it when we started working on the 6th generation ZR1. So remember that car, 638 horsepower. We had a 505 horsepower naturally aspirated, very lightweight Z06, very well balanced, 50-50 weight distribution. And we're working on this supercharged beast, and we were petrified heading for production that it would be slower, 0 to 60, than our 505 horsepower Z06, because big engine, heavy engine, supercharger on the nose. It was a 52-48 car, and it wouldn't hook up very well. So we eventually, very sticky tires from Michelin, a lot of calibration on launch control, we eventually eked out, a small victory, but you could see then the handwriting was on the wall. We weren't going to be able to push this very much farther. So that's what started us thinking, sometime in the future, if we're going to keep pushing the performance envelope out farther and farther, we have to consider this. And actually, we worked with Pratt & Miller way back then on, I'm not going to tell you anything about the car. I'm going to give you round numbers on horsepower, vehicle mass, tire performance, and you guys vary the weight distribution and tell us what it does. And so they created a model that did lap time simulations and showed us, you get 2 rear heavy, it's bad. You get 2 front heavy, it's bad. There's a sweet spot around here that is great for a race car. If you look at race cars, Formula 1 cars even, they're 60-40, something right around there. And so we had analytical evidence that that was the sweet spot to be, both from straight line performance and track performance.
Is that what you are now, 60-40?
60-40, yeah.
Oh, no kidding.
Yeah, depending on option content,
yeah,
but it's right around there. So that started, and actually Harlan Charles, our marketing manager, started putting together some information that basically took off from Zora's dream and the reason, his rationale, because this was not a comfortable place to be, quite honestly. Bob Lutz was Dave Hill's boss at the time, and he said anybody caught working on a mid-engine Corvette is going to be fired. And his history was people wanted to do mid-engine because it was exotic, because it was cool, not because it was the scientifically correct way to do it if you did it right. So we kind of quietly started putting together some of this information. And then I said we had evidence of the customer acceptability. We actually did, I say we don't do clinics. We don't do clinics around specific cars, but we did do a proportion clinic that didn't have any style, any content in it that related to us. It was strictly proportions, and it was just exterior appearance. It had nothing to do with getting in, climbing in and out of cars. And we took a whole bunch of people and we showed them just a generic design in the different proportions to get that data. So we had that data, so we had sort of the demographic logic of it, we had the scientific logic of it, and even back in Dave Hill's time, so this is 2005, we were putting together presentations on why it was at least worth studying. Not that we're going to do it, but let's get permission not to get fired, to study it, kind of above board.
Yeah.
And I ended up presenting directly to Bob and Rick Wagner in the time, because everybody was kind of dead set against. We had this business that was doing very well, basically working overtime through the whole life cycle at C5 and C6, and people are saying actually the same exact thing as they said in Zora's time. Why would you mess with something that's working perfectly well? And so we had to overcome that resistance, and it took quite a while, but eventually we overcame that and actually started down the road of doing it for the 7th generation car. Now, bankruptcy happened, 2008, crash happened, and so all those plans had to be set aside, unfortunately. But we spent a lot of time learning, thinking about it, doing some basic spade work that really helped us out when we got going on the program for real.
Did you guys ever consider just going with both of them at once? Like, hey, we'll do a front engine and we'll do a mid-engine?
Yes, that's a lot of mouths to feed to try to keep both fresh. But early on in the program, since there were so many doubters about this car, this is, when you see it now, you can see how good it is. At the time, nobody knew how it was going to turn out. And so there was a lot of people inside the company saying, we should hedge our bets. We should still offer the old car and the new car. But as this one took shape, people could sit in it, could see the styling, could see the performance, could drive it for themselves in some of their early integration vehicles. And ultimately, we did this big show where we parked the C7 Stingray and showed where we were headed. And everybody, all the way up to the board of directors, said, "You're not going to sell that old one. If you have both those on the lot at the same time at similar price points, you're not going to sell the old one." And so we said, you know what, we're just going all in on this one.
So an early concern was that the Corvette faithful would not take to a mid-engine car, and therefore you had to stick with what you knew. And
That was a lot of people had that concern. Yep.
Yeah,
And there are some
amazing.
people who, to be perfectly honest, say, "Well, it's a nice car, but it's not a Corvette to me." There are a few, a handful of people saying that. I think eventually they'll get over that. But we didn't know how big that crowd would be. Some of our customers are very conservative. They don't like change. I've been personally impressed with how many of our current customers have embraced it. Immediately, we're face-to-face with customers, people we've known forever, have sold generations of cars to. And so it's really heartening to see their reaction, see their excitement around it. It has gone better than we expected, honestly.
Yeah, no, you guys made the right decision for the physics reasons that you explained and because of the demographics. You're going to bring a whole new generation into Corvette right now. You just breathed a lot more life into this brand.
Honestly, we didn't have a choice. People say, "Oh, you're so brave to make this." We didn't have a choice. We had to do this.
but you were brave.
Yeah.
It was, yeah. I mean, we had the Corvette faithful. We're talking about the core people before who were true believers that we were doing the right thing. And no matter what challenge we'd come up against, it's worth overcoming. We've got to figure this out.
Yeah. Hey, we're going to wrap this up, but we're going to close with a phone call here from Clem. Carmen, let's bring that in right now.
This is Clem Zarobsky in Delmont, Pennsylvania. As a previous owner of 11 new Corvettes, I just want to thank Chevrolet for making that type of car available and affordable to a working person like myself. Thank you very much. Bye.
Well, there you go.
There's one.
There you go.
Thanks so much, Clem. We really appreciate it.
For many people
Yeah.
like that, and
Yeah.
we are really trying to encourage dealers not to mark the car up. We've announced we're putting a second shift on at Bowling Green, so we're hoping to build to demand, and we're hoping that people can actually buy the car at the price. I know there's rumors out there we're going to jack it up to $80,000. No, we're not going to do that. We're putting on a second shift in Bowling Green. We want to sell in our traditional volumes, if not more, if we bring new people in. So, and also while I'm on the subject, there's a lot of rumors that it's all sold out already. The pipeline of orders is very full. There's a lot of people expressing interest, but we don't want to discourage people. Things happen. If people are interested in the car, talk to your dealer. Make sure they have allocation. And like I said, we'll build as many as we can.
That's right. Look, thanks so much for coming on the show. Tadge, it's great having you back on here. And we barely scratched the surface.
There's a lot to talk about on this.
There's a lot to talk about, and I hope that's what people leave the show with, the appreciation of just how complex it is to develop a car.